What if you could be in two places at the same time? Welcome to the quantum world where this bizarre concept is a reality. Now let's step into the realm of quantum mechanics, a branch of physics that dives into the enigmatic behavior of particles at the atomic and subatomic level. It's a world that defies common sense, where the laws of classical physics are put on their heads and reality as we know it seems to take a back seat. At the heart of quantum mechanics is the concept of wave-particle duality. Particles like electrons or photons can behave both as particles and as waves. This means they can exist in multiple states at once, a phenomenon known as superposition. Imagine a coin spinning in midair. It's neither heads nor tails, but both at the same time until it lands. That's superposition for you. But how can something be in two places at once? Well, in the quantum world, it's not about where a particle is, but where it could be. It's a world of probabilities, not certainties. This idea might seem strange, but it's been proven time and time again in experiments like the famous double-slit experiment. It's important to note that these quantum effects don't typically show up in our everyday lives. Why? Because they're often washed out by environmental noise or interactions with other particles. But under the right conditions, like at very low temperatures or in isolated systems, these effects can be observed. And when they challenge our conventional understanding of reality. But don't let these mind-bending concepts deter you. Yes, quantum mechanics is complex and counterintuitive, but it's also tremendously exciting. It's the science behind lasers, semiconductors, and even the future of computing. It's the key to understanding the fundamental nature of our universe. So, in the quantum world, the impossible becomes possible. Intrigued? Let's dive deeper. Imagine if knowing more about one thing made you know less about another. Sounds strange, doesn't it? Welcome to the Heisenberg uncertainty principle. In the macro world we're used to, this concept seems absurd. If you're driving a car, the more you know about its speed, the less you know about its location. That's not how things work, right? But quantum mechanics doesn't play by our everyday rules. The Heisenberg uncertainty principle is a fundamental principle in quantum mechanics. Simply put, it says that you cannot know both the exact position and the exact momentum of a particle at the same time. The more precisely one measures one quantity, the less precisely the other can be known. Let's use a day-to-day analogy to simplify things. Imagine you're at a party and you see a friend dancing. If you focus on the exact position of your friend's feet, you may lose track of their overall movement or rhythm. Conversely, if you concentrate on the rhythm or momentum of their dance, you may not be able to pinpoint the exact position of their feet at any given moment. Now, apply this to the subatomic world. For particles like electrons, the more precisely we know their location, the less precisely we can know their speed or direction, and vice versa. This doesn't mean our measurements are flawed or our equipment is faulty, it's just the nature of the quantum world. The very act of observing changes the observed. This principle has profound implications for our understanding of reality. It tells us that we can't predict the exact behavior of individual particles, only their probabilities. So in the quantum realm, the world is not deterministic, as we're used to thinking. Instead, it's probabilistic. It's not about knowing exactly what will happen, but about the odds of different possibilities. In the quantum world, certainty gives way to probability. But that's just the tip of the quantum iceberg. What if your actions could instantly affect something light years away? This isn't science fiction, it's quantum entanglement. Quantum entanglement is a concept that seems to defy the very fabric of reality as we know it. It's a phenomenon where two particles become intertwined in such a way that the state of one particle instantaneously affects the state of the other, no matter how vast the distance between them. Imagine for a moment, two dice, light years apart. In our everyday world, the roll of one die doesn't affect the other. But in the quantum realm, these dice are entangled. When you roll one, the other somehow knows the result and mirrors it instantly. This communication between the dice happens faster than the speed of light, something our classical understanding of physics deems impossible. You might be wondering, how do particles become entangled in the first place? Well, it often happens when particles interact or share a common origin. For example, a decaying particle might give rise to two daughter particles that zoom off in different directions. These daughter particles are now entangled. Even if they journey to opposite ends of the universe, they remain forever linked. Quantum entanglement challenges our concepts of space and time. It suggests that distance may not be as straightforward as it seems, Could it be that these entangled particles are communicating via some higher dimension we're yet to discover? Or is there something fundamental about the universe we're missing? These are the questions that keep quantum physicists up at night. It's worth noting that while quantum entanglement has been proven in the lab, we don't yet fully understand it. We can't, for instance, use it to send messages faster than light, or to teleport objects Star Trek style. At least, not yet. Einstein called it spooky action at a distance, and it's one of the most mystifying aspects of quantum mechanics, but there's more to uncover. Ever wished you could walk through walls? Quantum particles can do just that. Welcome to the world of quantum tunneling. Imagine a ball at the bottom of a valley surrounded by tall, steep hills. In the world as we know it, for the ball to appear on the other side of the hill, it would have to roll up and over, right? But what if one moment the ball was in the valley, and the next, it was on the other side of the hill, without ever having climbed to the top? Seems impossible, doesn't it? Welcome to the world of quantum tunneling, where the impossible becomes possible. Quantum tunneling is a phenomenon exclusive to the realm of quantum mechanics, where particles, like electrons, can pass through barriers that would be impenetrable in the classical world. Picture our little ball again. In quantum terms, the ball is a particle and the hill is a barrier. The particle doesn't have enough energy to get over the barrier, but instead of being trapped forever, it can just tunnel through. So how does this happen? Well, quantum mechanics tells us that particles can exist in a state of superposition, meaning they can be in multiple places at once. So, while part of the particle might be reflected back, another part can continue forward, effectively digging a tunnel through the barrier and appearing on the other side. You might be wondering, where do we see this in the real world? Well, it's actually at the heart of many technologies we use today. For instance, in the flash memory of your smartphone, electrons use quantum tunneling to move data around. Even the sun owes its shine to this phenomenon, with particles in its core tunneling through immense barriers to trigger nuclear fusion. Quantum tunneling is a mind-bending concept that defies our everyday understanding of the world. It's a reminder that on the quantum level, the rules of the game are entirely different. Quantum tunneling defies our common sense, but in the quantum world, it's just another day at the office. Quantum mechanics, a realm where particles can be in two places at once. Uncertainty is certain, actions can have instant effects at a distance, and walls are merely suggestions. We've taken a journey today through some of the most mind-bending concepts of quantum mechanics. Starting with superposition, the idea that particles can exist in multiple states simultaneously until observed. It's like Schrödinger's cat, both alive and dead until we open the box. This principle challenges our conventional understanding of reality and forces us to accept that the quantum world doesn't play by the same rules. Then, we delved into the Heisenberg uncertainty principle, a cornerstone of quantum mechanics, which states that we cannot know both the position and momentum of a particle with absolute certainty. The more we know about one, the less we know about the other. It's a principle that teaches us to embrace uncertainty as an inherent part of the natural world. Next, we explored quantum entanglement, a phenomenon so strange that even Einstein called it spooky action at a distance. When particles become entangled, they can affect each other instantaneously, no matter how far apart they are. It's a concept that defies our understanding of space and time and opens up exciting possibilities for technologies like quantum computing and teleportation. Finally, we touched on quantum tunneling, where particles can pass through barriers as if they were mere suggestions. This principle is at the heart of many modern technologies, from the humble flash drive to the awe-inspiring solar panels. These principles of quantum mechanics challenge our everyday experience of the world and stretch our understanding of reality. They push the boundaries of what we thought was possible and open up new avenues for scientific and technological advancement. Quantum mechanics may be strange, bizarre even, but therein lies its beauty and its power. Quantum mechanics may be strange and mysterious, but it's this very strangeness that makes it one of the most fascinating fields of study. Thank you for joining us on this journey into the quantum world.